Hello world. My name is Silver Pang, and I'm a software developer in a B2B data engineering team at Expedia Group, and I'm actually based in London. And it's my honor to be here today. And I'm also a proud survivor of three Airflow migrations, with another one for Airflow 3.0 looming next month. So not just to share my experience here, but more importantly, to learn from all of you in this great community, as well here, especially in person. I've been wrangling Airflow at an enterprise scale for about 5 years. And if there's one philosophy that has helped me navigate through the constant change, is to be like water, which I'm heavily inspired by a great person based in Seattle before. So if you wanted to know who he is, feel free to connect to me after the talk. And we have heard about blockchain several years ago, and now AI is flying around everywhere. But some things in core is being constant. Like data orchestration is always needed. Data flow like waters, pipelines are with us, and our job is guide that flow. No matter how the landscape of the technology shift, data pipeline is not changing as the core functionalities. It's just more like input, process, output. Like nothing is more difficult than that. However, us, we must be adaptable, persistent, and fluid. And yeah, that's my little story. And today, I would like to talk about the journey in my organization from chaotic. It doesn't mean that it is bad. It's just always about the trade-off. It's about the journey, how Expedia Group manage Airflow deployment across hundreds of teams. A challenge that can quickly become complex, leading to bottleneck and slowing down innovation. And I will share our journey of decentralizing it to different Airflow repository to empower our data engineering team through a multi-tenant platform. And all from the perspective of a data engineer or software developer like me, collaborating with a central platform teams. So disclaimer here, all the work is mainly contributed by the platform teams at my company. So kudos to them. And the following showcase is more from my perspective in the organization. So before we dive in, let me quickly define what I mean by the platform engineering. So they are the architects responsible for designing, building, and maintaining the shared infrastructure and tooling that enable development teams like me to run the workflow reliability securely. And they set up all the guardrails for us. And they build the riverbeds so our data can flow smoothly. And let's rewind the clock about 7 years ago at Expedia Group. We had a sort of hidden agreement back then, an unwritten rule. Every team have their own data pipeline, have their own style, end-to-end development cycle. So on the surface, this sounds great. Your team might have full ownership, total control, but in reality, it leads to what I call it siloed innovation. And we end up with countless styles of deployment. And some teams were really hardcore, like using plain cell script and sudoing directly to the EC2 instance. Some of the team, when I look at them, the screen is always black and white. I'm not sure what they're doing at that moment. But other had built elaborate system, like with Terraform and Ansible script. But there's one case that I remember is one of the team that's still using the default executor for the Airflow back in the time, and they can't run multiple pipeline at once. But me, for myself, I don't believe that there's a single correct way to do things. Traditional approach aren't necessarily outdated, but this diversity creates a hidden tech debt on our developers. Teams are typically formed around business domains, and their primary focus should be on delivering business value. not becoming like expert into the like infrastructure management and constantly having to maintain and upgrade your own workflow orchestration tools on top of your core responsibility. And that could give us like a nightmare. So I'm sure that I'm not the only one whose career has been a series of never-ending migration projects. And this question wasn't whether our developer could manage their own infrastructure or not. Of course, they can do it. They are capable. But the real question was to the company, should they? Since our team and company is formed based on the business domain, but not by the tech stack. And the constant reinvention of the wheel across the team led us to a turning point. And we recognize the true cause of the fragmented approach was the cognitive load it placed on our engineers. So the time they spent researching the best way to deploy a DAG, secure a connection, or fixing a security patch was the time they weren't spending on building their own data products. So this is where our platform engineering teams stepped in. Their mission was to shift our paradigm. Instead of every team building their own dirty road, the platform team would build a shared multi-lane highway system, and this system provides a standardized, secure, efficient path to production, while still giving teams the flexibility to choose their own vehicle and destination. They also provide a toolkit for us. So there will be a data processing framework. So for example, all the read-write method for our Hive or Iceberg table, the connection to the S3 or SQL database, or even Elasticsearch instance. And they also provide the guidance on the data movement. What would be the allowed pattern for different environment to ensure that we have a good guardrail for our data, not being exposed to the wrong team and wrong environment. And here's the simple graph of the multi-tenant structure of the Airflow, and it's our core strategy. Instead of one monolithic Airflow instance or 100 of completely disparate one, we created a platform that could provision isolated and self-contained Airflow environment for each team. So what does like the multi-tenancy actually look like for us? At its heart, it's all about isolation. We leverage Kubernetes to create those like isolated environment. Each teams or tenant get its own Kubernetes namespace, and this is a critical design choice. It means that team A can run a completely different set of Python dependency from team B without any risk of conflict. And their DAGs, their connection, their workload are completely separate. This namespace approach also solved a huge security and compliance headache at our company. It is configure or assume a specific IAM role with the least privileged access. And it also connected to our centralized HashiCorp Vault instance to fetch only the credential it is authorized to see. This makes the integration incredibly simple for developers. They don't need to set up their own vault and worry about complexity of data access policy. And this platform provides a secure foundation by default. And to manage dependency, each team has its own like Terraform file and Docker file in their team. So this is an example of a Terraform file in our company. So we have like around 200 of them to set it up. So like if I want to set up an Airflow Seattle team right now for this community, I can simply like name the client or the application name and specify the Airflow version, which should be 3.0 since we are all interested in. And we can add the vault secret key, and most importantly, our company care about the cost attribution to different teams. So we just need to simply fill in the Terraform file, and then we can spin up our Airflow clusters. So it's like a black box on how it created, but the platform team handle all for us. So for some specific teams that has their flavored like Python dependency, they can also add it to the file from their team. This gives them the freedom to install any internal operators that they need, and the platform team would just need to maintain the secure and scan base image when it built. So it helps us to strike a perfect balance between the standardization and the flexibility. And I would call that the architecture is powerful, but its success on the developer experience, it will be hints on that. If it is hard to use, no one would adopt it. We have to persuade every single team to use the platform team solution. So this is where the ETL pipeline repository templates comes in. We might sometimes heard about time to deploy, and how do we measure the time to deploy for a brand new pipeline? And our goal was to get this as close to zero as possible. And at Expedia, we are using Backstage, our internal developer portal, a team that can generate a new production-ready data pipeline repository in minutes. So we can't do it in seconds since there's a lot of stuff to fill it in for administration. But it will help us to deploy the ETL pipeline to the targeted Airflow cluster. So instantly, and after we generate it, the GitHub repository pre-populated with the boilerplate of the code and utilities, the DAGs and the test would be all provided through the Backstage template. And also, there will be a CI/CD pipeline fully automated that I will show really soon. So this simple act empowers our teams to focus almost entirely on the business logic of the DAG without worrying about underlying Airflow configuration or any kind of deployment mechanics. And here's an example of our Backstage template on how we have to fill it in. We might need to fill in some application name, which is sometimes the most difficult thing to fill in, and some environment scope, whether the data could be sensitive or not, and some of the application lifetime, let's say, could that be productionalized in the future soon, or is just a POC project? And that's bring us to the CI/CD pipeline, like an engine room, and our streamlined CI/CD process and the reusable deployment workflow is provided by the platform team. And I would make a big compliment for that, because when we are pushing a change, so I'm going to show it in action. After we create a pull request, make our change, getting reviewed by our team, it will automatically trigger the get back actions for us. It will run all the tests, integration tests that it needs. It will scan for vulnerability issue, and it will help us to build the jar archetype and the Docker image. It helps us to deploy to the centralized artifactories. And after that, our company also use Spinnaker and Jenkins to sync all the DAGs variable connection to our designated Airflow clusters. So we have to specify the team clusters here and the environment in a simple config file. And the pipeline will handle the rest to upload it all to the S3 bucket. And our DAG would be appeared on the Airflow. And that is almost like a no-look deployment. And in the pull request, we would have the status check for everything that makes sure that everything is deployed properly, passing all the checks. So no developer intervention at all, except when we are deploying to production. We need a one-click deployment to production, since we need a manual judgment. And this automation is a game changer. It dramatically reduces the chance of manual deployments error. It also standardizes the process across the entire organization. No more wondering how Team A is getting their codes out. Everyone follow the same battle test, secure process, and this frees up all the DevOps and the platform engineers from handling routine deployment queries. allow them to focusing on improving the underlying infrastructure. And we even have the automated utilities and that can handle the DAG cleanup. So when a DAG file is deleted from the repository, the pipeline will ensure that it will also removed from the FOUI as well, which prevents the clutter and confusions. And more than that, like health check, the healthiness of the Airflow cluster is all also handled. And we will get the report like weekly of the score on how we manage our Airflow for each teams. But there would be like some trade-off since every team still need to clean their own stuff on their Airflow clusters. But I would say the consistency and the automation in our organization would be well worth it. So what has been the result of this journey over the 6 years? So I got some numbers here. Compared to the other company just present in the same conference, we might not be the biggest number yet, but we are currently running over 200 isolated Airflow cluster and serving more than 180 engineering teams across the company. And the platform orchestrates over 14,000 unique DAGs, which translate to 1.5 million task execution every single month. And the adoption is still growing. And people at our organization is still creating the pipeline from our backstage templates every month with over 20 new pipeline. So before that, for a team to set up and manage their own cluster, it is easily to take a full week of a full-time engineer effort. But today, with the platform, we just need to fill in some files and some template, and it just takes the same engineer about a day to configure what they need, and maybe plus a day of the support from the platform team. So I would say roughly around 50% reduction in effort. And for the DAG deployment, the deployment times varies around 5 to 15 minutes ago before that with the custom CI/CD pipeline. But now we got a standardized way, so everything can be deployed easily within 5 minutes. And this 5 minutes is across every single team, so there's no big difference from them. So the real saving is the elimination of the DevOps overhead on each team. So imagine we got around 200 teams for that. So these multi-tenancy models can also provide other benefit. Let's say easier chargeback. We can attribute infrastructure costs directly to the team that they use the resources. And on control, each cluster is configured with the only permission that it needs, rather than the one-size-fits-all role. And the phased migration, and now we are going to have the 3.0. This mechanism allow us to have multiple versions of Airflow to coexist, because not all the teams can migrate to the latest version at the same times. And this allowed us to upgrade on their own schedule without holding anyone else back. So for me, I'm actually the first team is going to upgrade to the 3.0 in our internal company beta program. So I'm taking a lot of notes from the conference. And there will be some also hard lesson that I learned throughout the year and wanted to be realistic. And this transformation wasn't a simple flick of a switch. We faced significant obstacles along the way. Firstly, we have the challenge of maintaining consistency across the decentralized repository. So how do we share the common utility functions or the variable without copy and paste the code everywhere? So our solution was twofold. We developed a centralized Python library for shared utilities, which teams can install as a package in their Docker files. But for variables and connection, we adopted a configuration as code approach. So managing them in a secure repository and syncing them via the CI/CD pipeline. And finally, there was a learning curve for that. we introduce like a new opinion like workflow for these cases. And when a new developer join my team, I don't think they can just start making the change on the day one. They might need to understand all the structure and the story behind the platform solution. This feels a bit like anti-pattern for the open source tooling. But we tackle it with the hands-on, with comprehensive documentation. We got our own like community support channel on Slack as well. So here's an example for one of the automated developer assistant that we created by our platform team. And since we have the custom operator, for each job that we run, we got a UUID for a job. So whenever people like paste a job ID over there, we can see like where they run, who runs it, what is the name, and if they're missing like access, what security group they should be joining. And it also check all the healthiness and the metrics of the F4 cluster, and it will show the version and the operator that we have at our company. So it helps us to save a lot of time on troubleshooting the error. And lastly, to bring it back all to the beginnings, what is the philosophy behind this journey? I would say there's no single solution or standard can solve every challenge that we faced over the years. And we have to remain flexible, like water. Our multi-tenant platform isn't a widget, a final product, but is an evolving system. It taught us to recognize every obstacle as an opportunity to refine our approach to overcome our limitation. And our key takeaway is a successful enterprise data platform is about finding the balance between like the structure and the flexibility that you can give to the team. We need a solid platform to act as a riverbed to providing security, reliability, and standardized tooling. And at the same time, we have to also grant developer autonomy to allow teams to innovate and to deliver their value at their own pace. And we also need a culture of continuous learning and adaptation to be the current, always responding to the new challenge and evolving business need. And now our next great challenge would be how we can migrate to the FO3 with the least time that we have. But with the adaptable foundation in place, I think we are better prepared than before, and we have built a system to allow us to navigate the changing currents of technology, but not fighting against them. And that's all I want to talk about today. Yeah. Thank you very much.